So today we're going to look at Decartes' rule of signs to tell us how many real roots and how many real positive roots and real negative roots that we have by using this kind of pattern that we're going to see. That's kind of the best way to describe it. Here's the kind of wording for it. So suppose you have a function p is a polynomial that has real coefficients and is written in standard form. So it doesn't need to be written in standard form, just meaning that, all the pieces are on one side, all the terms are on one side, and they equal the function. So the number of positive real zeros of the function is either equal to the number of variations in sign of the function or less than that by an even number. And then it's the same idea for the negative. So all the negative real zeros, or the number of negative real zeros of the function, is either equal to the number of variations of the sign of the negative, the opposite of the function, or we're going to flip all the signs, or less than that by even number. So I think it's much easier to show you what that means than to try to talk through it anymore. So we're going to take this function, and this should be on your notes page for sure, so you can see this. So we're going to look at positive real zeros first. So for g of x, there are so many variations in sign. So what we're going to do is we're literally going to go from piece to piece and just say, does it go from negative to positive, positive, negative, or does it stay the same sign that it already was? So in this case, I'm going from negative to positive. So I note that here, I'm going from negative to positive. That's a change. Okay. Now I'm going from positive to negative. Okay, I've changed again. I'm going from negative to positive. I've changed yet again. And on the very last one, I'm going from positive to positive. So that's not a change. But I did change 1, 2, 3 times. So that means that there's 3 variations in signs. So I can either have 3 positive real roots, or I can go down by even numbers. So it's either going to be 3 or 1, because I can go 3 minus 2 is 1. If I tried to subtract 2 again, I'd be below 0, so I don't go below that. So note that 1 is less than 3 by an even number, but specifically by 2. Okay, so if by chance you had a really, really long one and you had, 10 variations, well, you could start with 10, or it could be 8, or it could be 6, or it could be 4. I could keep going down until I got to 0 by variations of 2, basically going down by 2. All right, so we're going to do the same thing with the negatives, but we do have to flip the function so that it's the negative function. So if you notice on this one, there's a negative. I'm going to put a negative here. So I gave you a space to put a negative in each one. So it's the exact same function, but I just gave you a space with the parentheses so that you could apply a negative to that x, because that's what we're going to do here. There should actually be a negative here so that it's a little bit clearer that we're finding the inverse, the negative of this function. So we're just going to apply that real quick. So make sure you apply the exponent first. So I have negative x to the 4th power. Well, since there's 4, that means it's going to be positive x. And there is a negative out front, so it is going to stay negative x, okay, in front. And then I have negative x to the 3rd power. Well, since there's 3 negatives, it's going to stay negative, okay? So I'm going to end up with negative x cubed. And then I have negative x squared. Well, again, it's even. Negative times a negative is a positive. It'll go through, okay? And it keeps cleaning itself up here as I'm going. So then I have negative 2, because that came down, times x cubed. Oop, that should be a square. Silly me. Because the cube is right here, that should definitely be a 2 there, not a 3. And then on this one, it's just negative x. There is nothing to cancel out, so it's just going to be negative 3x. And then on the end, it's plus 4. Okay, so we just went through and we applied the negative. Just make sure you're paying attention. You're applying it with the exponent first, and then multiply by what's in front, okay, so that you get the correct signage here. So now when I go from the beginning, the first to the second, I'm going from negative to negative. There's no change. And then I'm going from negative to negative again, no change. Negative to negative again, there's no change. Negative to positive, so there is one change here. So for g of negative x, there's only one variation in sign. So according to the Decartes rule of signs, there's exactly one negative real zero. So this is just, it's a way of looking at the signs, and I know that this one's a little bit more spread out, but it's just that idea. First, just go through and how many changes do you have? So if you have more than 2, you can go down. You're either going to have 3 or you're going to have 1. Now we're talking about real zeros. So we are going to have 4 zeros here, but some of them may not be real zeros. And we were just doing the quadratic formula on the last video, which showed us we did have imaginary roots. If you end up with a negative number under that square root sign, right, when we were doing that. So this is just simply telling us real positive or real negative numbers. It's not giving us every single zero. So that is how you use the Decartes rule of signs. I hope that helped, and I'll see you on the next video.